Hello and welcome to Mr. Alex, and today I'm gonna share with you how to do the simulation of the pressurized pipe. This will be the first tutorial, so we will try to make it very simple. So this is the interface of the software. We have the pre-post. This one is to develop the model, for you to make the model and to process the results. So here are the files I got from you. So we have many files. So since this is the first tutorial, then I will just try to make it simple and work with only one part. So we can just take click on file and import IGS file, or simply you can take this one and just drag it here. Okay, now he will ask for you for you need to specify few things here, but the important thing is the unit. So the unit, just make it millimeter. Okay, so now we have, this is the geometry from your side, the IGS file that you make. Okay, the first thing that we need to do, we need to mesh this part, or we need to mesh this solid geometry. What we mean by mesh, meaning we convert this one from geometry to finite element. We will break it to small elements, and then after that we can run our simulation and analysis. This is a geometry file, cannot do any analysis on it, on this geometry. So to mesh it, I go to mesh, then go to auto measure. Okay, so I click on whole, meaning I want to mesh everything. See, you can see here 44 geometry, meaning in all this we have 44 surfaces. And then I click on compute and then mesh, and now you can see this is our mesh. Okay, you click on control and you scroll with the mouse to zoom in and out, and you hold the middle of the mouse so that you can move left or right. Okay, so I want to recheck this one and try this variable size mesh. I click on active again, I compute and mesh. Okay, now we can see our mesh sizing is better than before, and here also you can see the elements are better than the previous one. So here I just want to make it let's say I want to make it 1, the minimum size. You can see here we have big elements, and here we have here big and here small. So the smaller size I want to make it 1, so our circles will be more smooth. Click on whole, then mesh. Okay, you can start working on now for the time being. Okay, and then accept. So now you can see we have two things overlapping. The red one is the finite element, and the white or the gray one is the geometry. So shape group, I just unclick on this. Now you can see we have only the finite element. And you can see here okay, I feel like this mesh is not good enough, so I want to remesh again. So I click on solid, and here I unclick on shell 1. Then I go to deviation, here I make it number 1. Click on everything and mesh. Okay, now you can see this is the sizing of the mesh, and the circle is much better. Alright, but here I want the element maximum size. Let's say I want it to be 10 and try to mesh. Now I think this one is acceptable, so I click on accept, and now I can hide here. I can hide my solid, and here I have the two parts. Okay, this one is the first one and this one is the second one. Okay, the first one I don't want it, so I can just right click and then delete. Yes, remove this one. So now I will start working with only this part. Okay, here you might see it looks like solid, but this actually we call it shell element. It's like only 2D element. If let's say I go to model, or I go to element tool and then go to blank meaning I want to hide. See, if I click like this, you can see these are only shell element. Shell element meaning it means that it is only in 2 dimension. Okay, so I'm blank. So what I want to do now, I want to know the thickness of this one. So the thickness is 5.5 millimeter. So I need to define the thickness of this shell element. So I go to model, go to keyword, and then click on all, then click on section, click on shell, and our thickness just now is 5.5. This, let's say number 1, this is pipe section. Okay, click on model. Now we have the section and you have the part. The part meaning this guy over here. So although that I defined the shell already, I need to link between this section and the part. So I go here and go to section, then click on pipe. Click on the pipe section. Here I will call it pipe. Okay, now what I want to do, I want to delete one of these shell circles. Here we have, first I will delete this part. So as I said before, I click here, we have like 2 circles here. So I don't want these 2 circles, I only want one of them. So what I can do now, I can delete the one inside. So I click the elements that I want to delete. See, if I click like this, it's only small one by one is selected, but I click on propagate and I increase the angle. So now if I click here, the selection will propagate and it will select everything. It will go deep inside. Okay, until here. So I can actually make this one 90. Okay, and actually 90 is too much. Now everything will be deleted. I just want to delete the one inside. So I select here and delete, accept. Now from this side also I have the same I do need to do the same thing. Select here and then I will delete. Okay, click on control and then the middle of the mouse, again you can see only the inside is selected, the one outside is not selected, so I can just delete, accept. Okay, now as I said, I want to link between the thickness of this shell, between the thickness that I defined and the part. And sorry, I did already here. Okay, so now if I do appear, click on appear, model, appear, and then show the thickness, then apply. Now you can see here, if I do like this, it will show the thickness of the part. Okay, so let's say if I go here and my shell thickness, I change it, let's say from 5.5 I put it 1, accept. Now it will become small. Alright, but our thickness is 5.5, accept. Okay, one more thing to take note of, which is very important. Here you click on solid, show the geometry, the IJS file, and you can see this is not overlapping, meaning our pipe is bigger. Okay, the reason why it's happening like that, because this black line represents our shell, and here the thickness is going from this side and this side. So what I can do, I can change here and the normal location and lock. If I put 1 and accept, now you can see the blue part is overlapping. Okay, so this end lock, meaning the location of the surface, that the location of the thickness, is it going out or going in, or it is like the mid surface. So you can read here, the explanation is nice. Okay, so I accept, done. Okay, now we need to do one more part, which is this support. Okay, first of all I click on control and control shift and save, because I want to save the file before anything happened. And the format for this software is .k. Okay. Sometimes my PC stop while I record, that's why I need to save from time to time. Okay, now for this part, this section is done. Now I need to make some changes here. Okay, why? Because this part is actually very thick. Okay, so I want to make it with a solid element. Okay, so here again I go to appear and just hide the thickness. Okay, this section, this circular part is actually very, what we call it, very thick. Okay, it's very thick from this direction. So what I can do is I want to make it with solid element. Now I want to, as I said, I want to make this one with solid element. Okay, there are many ways how to do it, but I will show one way in this the method that I think it's more there are a few ways to do that, to mesh this one from shell to solid. Here I will show the most suitable way in my opinion. First I measure this one from here to here is 22. Okay, go to element tools, measure, and click on 2 points, and it will show you the distance. Distance 22. You have the drawing, so I think you know. Okay, now I delete all this part. Okay, so go here, I delete propagate, I delete this surface, this one, and this one. Okay, here also I delete this, and all these circles I delete them, and then I go to mesh, element generation, and then the solid, make it number 1. Now the thickness, remember the thickness 22. How many segments? Maybe I put it 3. then I will extrude this in the negative direction. So if I click, now you can see I will have the same like before. Okay, so this one I make it 3 layers, and then I can accept. Okay, now I have the pipe and I have the support. Okay, this is made from solid element and this is made from shell. Okay, now since I already have this red support, I can delete this ring. So I go to element, edit, delete by element and propagate, delete this one, and here also I delete this one. Okay, now I go here. Now everything is working fine, everything looks perfect. Okay, so this you can see here, if I click on shell it will show only the shell parts. If I click on solid it will only show the solid part. Okay, now I go to, I want to show you the difference between the two elements. I can go to here, section, and then normal to X. Now from here, negative. Now you can see here the red one which I made from solid, it has something inside, right? But here the shell is very thin, it is only 2-dimension element. Now I go to off. Okay, now we are done with the geometry. We're done with meshing the geometry. Now we can proceed with our analysis. Okay, here we can proceed with the keyword. So first I define the section of this shell, right? So I define this section as shell. Now I need to define the section for here, for this part, as solid. So solid, here I put solid section ID. I can put any number as long as it doesn't clash with this one. So here put leave it as default is okay. No, it's here we have already 1, so let's say I make it 3. Okay, see here we have 1, right? I want to change it to 2. It's not necessary, it's not compulsory, but I want to change this to 2 because this part is part number 2. But you don't need to change it anyway. So here I put this solid, the solid as 1. Okay, now I go to model part. Now we have 2 parts, right? Part number 1 is the red one. Let's say I call it support. Here I link the section, solid section. If I link here, the simulation will not run, it will give you error because this one is solid, but you are linking, you are assigning if you assign a shell thickness to it, it will not work. Now accept. Okay, here you have material ID, so we need to actually define a material for this. Okay, so the material will describe the stress-strain relationship of the material that make these 2 parts. So here I go to material, and then here I will start with an easy one, which is power law plasticity, and here we have the input that we need to define. Okay, I go here to Google first, or first I want to put new. In this one I call it cast iron. Okay, the density is 7.197 E minus 6. Okay, why this one is in E minus 6? Because it is in because our length here is in millimeter and the weight is in kilogram. So this one is in this density is in kilogram per millimeter cube. Okay, our unit here must be consistent. And to know more about the unit consistency, you can see here from this website. I will give you the link. You can see here in our case we use the mass, we use our length in millimeter. Remember in the beginning of the video I defined the length as millimeter, the mass in kilogram. So if the length in millimeter and the mass in kilogram, we need to stick with this. You see here he gave a density of steel 7.83. In our case it's cast iron, so 7.1 E minus 6. The important part here is E minus 6. Okay, now the Young modulus. The Young modulus is 89.632. Okay, this one in gigapascal. So I go back here again. You can see here, if we are using this system of unit, then the stress and the strength of material should be in gigapascal. So this one is in gigapascal. Alright, Poisson's ratio, it's 0.3 because it doesn't have any units. Okay, now this we have K and N, and we have other things to define. Okay, what are these things? As I said before, the material model is like the equation that describes the stress strain curve for the material. Here is the standard stress strain curve. Okay, and we are using here power law plasticity, meaning in the plastic region it will model the behavior as a power exponential power function. You can see here, this is more in these slides, it's more obvious. You can see we have this part is defined as here, the red one, and this is given as the function. We have two parameters, okay, this H and this M. In our software it is called K and N, but they are the same thing. You can see here strength coefficient and hardening exponent. One of them is the coefficient, the other one is N is the exponent, same like here. One is the coefficient, the other is the exponent. Okay, so we have this one. If you remember, if you see here, we already defined the Young modulus. The Young modulus meaning the curve of this part. So this part is already taken off. We are already considering this part when we define the Young modulus. Then for this part, as I mentioned, we are using exponential form to approximate this part. Okay, now this one is the input of the function, which is the plastic strain, and this is the Y is the plastic stress or the strength of the material. Okay, for the cast iron we have here 0.26362. This one in gigapascal, so if I convert it will be 0.26362 megapascal. And so you need to remember from here, we are for the stress and the strength of material we are using gigapascal, and then for N the exponent 0.032053. And this strain parameters, if we need to define the strain rate effect, but for this simulation we gonna assume it is a slow static problem. Sigma yield, there is no need to define, this one is optional. And then this is the failure of the material. So the failure will happen when the plastic strain will reach 0.0027. Where I get these material properties, I will give you also the links. Okay, of course I'm using this cast iron only as an example. we can use a different material, and we can use different material properties. Here we have Johnson Cook, for example, is very famous, and here we have piecewise linear plasticity. Also, this one is commonly used. Okay, so now we define the material already. So I need, again, like before, link the material to the part. Both of the parts are made from the same material. So this is one. This is also one. Okay. Now we have defined the material, the geometry, the section. We need to define the boundary condition. So I can go to here, create entity, and then a boundary SPC. This SPC means spatial point coordinate. Sorry, meaning it will be fixed in their own coordinate, not in the global coordinates. So I go to create this side. I want to fix it, so it will fix in all direction. So here I click on by node, then create by node. I click by edge. This is edge, and you can see I click like this, select the node of the edge. If I click on propagate, it will select all around the pipe, then accept. This is the first boundary condition. Now the second boundary condition is here. Okay, around this the places where the bolts go in. So here again I click on propagate, need to increase the here I can select by element and propagate, because we have more than one layer. We have 1, 2, 3 layers. You can see through the thickness. So I select by element and propagate. Now everything is selected, then apply, and it's fixed in all degree of freedom. Okay, X, Y, Z, meaning it cannot rotate in X or Y. It cannot translate, meaning it cannot move in X, Y, Z. R, X, R, Y, R, Z, meaning it cannot rotate around X axis, Y, or Z. Okay. Now we need to do a small thing here, which is duplicate the node, just to double check if everything is working fine, if everything is fixed. So show duplicate node. Here we have two nodes here are not fixed, fixed together. So I click merge duplicate node and accept. Okay, I go back again to the section view, model, section view, click on negative. Just want to make sure. Okay, you can see here, this is actually the remaining from the previous inside circle, so I need to delete that, because we already defined the thickness, so we don't need this. So here I go to element tools, element delete, then delete, propagate, delete this. Yeah, delete and accept. Right, so now here I save. Control S. So now I save. If I open here, you can see this is your file. Okay, now we need to apply the internal pressure. Okay, we apply the pressure on a surface, so we need to define a group of surface. This is, we call it one segment. This is another segment. This is another segment. So we need to define the segment. So we go to model, create entity, and then set data, set of segment, and then create by element, propagate. Now we create this one, and also we create this one. Then we create, then we click on apply. then done. Okay, alright, this one we don't need to show it, we already know, so we click on show none. This node also just click, sorry, this one also click none, no need to show, we already know they are there. Okay, now we need to define, sorry, model. We need to know the normal of the shell element. Okay, click on normal here and then show normal, then by part. Okay, make it a bit smaller, 0.1. okay, so you see the normal is going out, so this is okay, meaning when we apply the pressure will go out. Okay, so now we go to model, keyword all. We need to define the pressure. Okay, so we define it as a curve, new, let's say this one is pressure. So when pressure is 0, when time is 0, pressure is 0, then insert. Then when, let's say, time is 1, our pressure, let's say, is 0.1 and insert. Remember, the pressure is like the stress, so this 0.1 meaning 100 megapascal. Then we accept. Now we define already the pressure. Now we need to also define the pressure curve, the load. If you plot here, you can see this is your pressure curve. You can play with it and make it constant or make it going up and down, up to you. But for here we just say it's constant and it's going up, sorry. Now we define the load, or we define the pressure on the surface or the segment that we did before. So load, we have segment set. Now we go to new. This is SSID, segment set ID, the ID of the group of the segment we already have here. We define it just now, number 1, and the load curve is the pressure curve. And here, let's say if I want the curve to be bigger or smaller, I can play with it here. So here I can say in internal pressure. Okay, go to model and go to set. We have the segment, right? Here, let's say I just want to rename it. I call it pressurized segment, then accept. Then from here I can go to segment set. I just want to show here is the same segment that I did just now. We defined the segment, but what I did before this just now is I just rename it so that the name comes here. Accept. Okay, now we need to define the control of this simulation, or before that I define the output. Okay, the output, let's say D3 plot. This is the time interval between the output. So let's say this is like how you control the frame per second. So if I put 0.001, meaning each 0.001 or one output will come out. Then I click on accept, or I can click on accept, and then this is enough for the database the time being. Or I can do also ASCII option. This is asking for extra input. So the default I put the same 0.01 and then enter. What I want to know here is the reaction forces. Okay, not this one. Oh, the boundary forces actually here, this one. Okay, boundary condition forces and energy, because we define the boundary at two sides. So I want to ask the software to give me the output of that, and accept. Done. Okay, almost finished. Now we need to define the control of this simulation. So first of all, I want to control termination equal to 1. 1 means in this case, what I'm going to do now, I'm going to use implicit simulation. Implicit simulation meaning we don't have any time, meaning the load will be applied very small. So this one doesn't mean 1 second or 1 millisecond or anything. Okay, this one is time, and but this value of 1 doesn't mean millisecond or second or anything, because I'm going to use implicit. So using implicit meaning the load will be applied very small. So here I need to define few keywords in the implicit. So first of all, implicit control auto. Here I make it 1, meaning the time step will change. I just change this one. The rest will leave it as default value. And then implicit general. Here I'll make it implicit analysis. And then the initial time step 0.001. Then accept. This initial time step, as a rule of thumb, it should be 1/1000 of your termination time. So my termination time is 1, so here I put 0.001. Okay, and else here implicit solution. Here the solver of the solution of the problem, it's 12. So we have actually non-linear. And then implicit solver, this is just leave it as default. And I believe that's all. We have one more, implicit dynamics. This is you can leave it as default also. Sorry, yeah, because we are using static analysis, so this one is 0. Accept. Now save. You can check the model, see if there are any errors. Okay, here keyword, you can see here no error, no warning. Here we have unreferenced node. Okay, unreferenced node meaning there are 2 nodes which are not being used. Okay, which are, you can see here, this one and this one, up and down. So I go to element tools, node editing, and then delete all unreferenced element node. See, you see there are 2 unreferenced nodes found. Then you delete, you accept. Now if I go back to model check, I need to close this one first, then open again. Okay, it still have not been re-updated, so I can click here recheck. Now we have no error, no nothing. So our simulation will run smoothly and no error. So I click on ls dyna. This ls dyna is the solver of the software, meaning I will make the file, the keyword file, the .k file using the ls prepost. Then I will run with this one, I will get the result, Then after I get the result, I open again with the ls prepost to show and view the result. So I browse, I go here, then this one, boiler, no, not this, yeah, this is the one. And then I make this one 4, meaning I will use 8 processor, not 4, I use 8 processor, and the memory I will put 1000 million. This is like the RAM memory that will be allocated for solving this problem. And then I hit enter. Okay, here you can see invalid output on the command line. Depending on which version you are using, for this version, you see there is error here, error, and you say A, right? This A is actually the same as this A. What does it mean? When we run, the name and the directory, everything should have no space, no nothing. Okay, underscore can, but no space. So what I want to do now, okay, this file, I save it, I close it. Now I copy, I paste here. Now I make a new folder with the same name. Now you can see there is no space here. Okay, you can see here there is no space, no nothing. Now it will run without error. It will not give the previous error. So here, this one, now you can see there is no space. Again, I want 8 processors to solve this one, because I want to reduce the time, because I'm recording now, and also the memory 1000, and I put M meaning billion. Now we just need to wait. See, now the outputs are coming out. This folder, the outputs are coming out. And one more thing, if you are using this software, for each simulation you need to put it in separate folder, otherwise the result will be overwriting. The new result will overwrite the old result. Okay. Okay, here we have a warning. If you start from the beginning and you scroll down, you see this warning. Hourglass formulation for part 1 has been switched to type 6. Okay, first of all, what is the meaning of hourglass? I can go here and explain with the picture is better. Hourglass. Hourglass in the finite element. So here, this is the hourglass mode of deformation. Okay, this hourglass, it's called hourglass because the shape looks like the hourglass. Okay, you can see here the shape is look like an hourglass here also. Okay, and what does this mean, or why this happens? This happens purely because the how the simulation, how the mathematics behind the finite element coding is written, and it is all the software have it, like also Abacus and ANSYS also have it, and there are few ways how to avoid this problem, and one of them to apply artificial stiffness, to apply or to assign artificial stiffness to the part so that it doesn't deform in the hourglass way. You can see here there is also another shape. Okay, and in this software hourglass number 6 is used. Okay, hourglass number 6, we have different type of hourglass and each of them have its own formulation, and this type number 6 is used because we are using implicit solver. For implicit it is compulsory to use hourglass number 6, type 6. Okay, if we scroll down here, this is still running. You can see here solid part failed at this time. This solid part failed. What does that mean? It means that the element has been deleted and there is failure in the element. Okay, so if I go here, I refresh, this means that the pressure that we applied is very strong. So what I can do here, I can just when I'm using this, okay, when I am on this, just click on it, then go to then hold the control, then click on C, it will stop, then I click SW1. Now it will stop the simulation. Okay, here I have the result. I double click here, or I can just drag the software. Now we can check our result. Okay, the elements here have already failed. Okay, the solid element here, and I can show the stress, or this is the stress. So the stress is actually bigger in this part. What else I can show? I can do this history, not history. I can go to here, setting, post processing, and then here the displacement factor. I want to see the displacement. So here I can say this one, let's say it's 10. So the distance is actually multiplied by 10 in this case. Okay, it's not obvious. Now what I can do, I can make it 50, apply. Okay, now you can see here the pipe has been actually shrinking, meaning the direction is wrong. The direction of the pressure is wrong, and because of that there is some bending here. Okay, there is some bending in the middle, and that happens because my pressure direction is wrong. I'm not applying the pressure from inside, I'm applying the pressure from outside. And why is that? Here I will open the file and I will show you. This is the keyword file. I will open again and show you. You can see here, because the normal of the shell, normal, you can see here, if I show normal and then click by part, you can see here what 0.1, you can see the normal is going out, so the pressure is actually applied against the normal. So what I can do, I can change the direction of the pressure. Okay, so to do that, click on keyword, load, segment set, and the pressure I make it -1. This scale factor will be multiplied by this part, but sorry, it will be multiplied by this curve. So now the curve will be going the other direction. So accept and done. Okay, now I don't want to apply the pressure here. Let's say I want to study the effect on the pipe itself, the pipe and the bend. So I remove this part from the segment. So click on the set data, okay, model, create entity, set data, segment, then pressurize segment, modify, okay, and then by part, then I right click on this one and right click and then accept or apply. Now this part, we don't have any pressure applied to it. Okay, so in this case the pressure is only applied in the pipe. Show and none. Then we save, okay, open the software. Now click here. First I need to close the result, then I click here, meaning it will rerun again. Okay, if I click here, you see it will run the same file again, the same file that it ran the last time. And now we can see the result, how it will be different. Okay, now we can see that there are some elements that failed already, so we can stop. Control C, then SW1. Now to run the result, I can just click on this. And click on OK. Here it will run it will open the most recent result. Okay, of course the pressure, we cannot see it. We need to increase the factor of displacement. Go to post setting from up here, then the displacement, let's say make it 50 and apply. Now you can see we have the pressure going out. Here also you can see that we have the pressure going and it's making it bigger and bigger. You can click on the stress, is the value of the stress as the time goes by. Okay, so I think that's all for today. It's been very long tutorial, so you will have the video. You can slowly at your own pace take it one by one. Okay, and hope you learned. I hope everything is clear, and if there is any confusion or any question, you can just ask me on Messenger. So see you next time.